In this video, we're going to go over the labeling of the periodic table. I encourage you to get a normal size periodic table, maybe even one that you can write on as we go through the labeling. I've tried to include periodic tables or images of them on each of the slides, but some of them are kind of small and hard to see. So if you had one that you could look at that's normal size, it might be valuable to you. So I want to remind us that the periodic table is organized by increasing atomic number. The location of the atomic number in the element symbol box is not a set place. So it could be in the upper right-hand corner, the upper left-hand corner, or like on this periodic table, they put the atomic number above the element symbol, like right there above the H is the number 1. And so that's the atomic number. The atomic number is equal to the number of protons in that atom. And so it's the number of protons that gives the identity to the specific atom. So no two elements have the same number of protons. We also have names for the columns and the rows on the periodic table. So just choosing a random column, which is the up and down, the vertical, this is called a group. And the groups can be identified usually one of two ways, and you can see it right above the group on the periodic table. It's either the numbers 1 through 18, and the one that I've circled, the group is number 14. Or you'll have a number with a letter. The letter will either be A or B. If it's a tall column, it's all A. If it's the columns in the middle, the letter is B. The one that I've circled is 4B. So if I were to identify that group, I would call it either group 14 or group 4B. You guys are probably like, A. I said B and then so 14, I'm sorry, or 4A. So it would either be group 14 or group 4A. Now we also can have the rows, so that is horizontal. And horizontal rows are called periods. And the periods are identified starting at 1 at the top of the periodic table and then just going down with the numbers. This one would be number 6 and this one would be number 7 because they are taken out of the periodic table right there in rows 6 and 7. So identifying the period that I have the line through, we would call it period 4. So we need to remember that the periodic table is organized by increasing atomic number, and that we call the columns groups and the rows periods. Now we also label large sections of the periodic table. We've already learned about metals and nonmetals in a previous chapter, so you can go back and review where those are located. But this is something outside of that. So we call, I'll outline it, all of the tall columns, so all of these, those are all called the representative elements. See that right there? Hydrogen is included in this, it's just not in this image. So the representative elements are all of these and all of these. Okay. Then we have the ones in the middle. And these are known as the transition metals or the transition elements. And then finally, our last large section is this down here, the part that is removed from the main body of the periodic table, and these are called inner transition metals or elements. Right here. The old or traditional ways of naming those two are called the lanthanides and actinides. They're based on the names of the elements right before we remove the inner transition metals. So from here, we need to know these three large categories. We need to be able to identify where the representative elements are, where the transition metals, and where the inner transition metals are. Then one of the last naming has to do with some of the groups that have their own names. It's the first two groups, so the two on the farthest left, and the last two groups, the two on the farthest right, that have their own names. So group 1A, and this does not include hydrogen, are called the alkali metals, so lithium and down. Group 2A is called the alkaline earth metals. That's all of them. Then if you go to the other side of the table, group 7A is called the halogens, and group 8A is called the noble gases. So these four columns or groups have their own names. Now, one thing that might even help one student is to notice that when you do these two groups, the two on the left and two on the right, if you go in order, their names are alphabetical from left to right. And I just mentioned that because many years ago I had a student who was had memorized the four groups but kept messing up when she was trying to place them on their periodic table. And she said what really helped her is to recognize that from left to right, they're in alphabetical order. That way she was never putting noble gases as group 1A. Because it was in alphabetical order, it has to be the last one. So that might not help you, but if it does, yay. So what I have here is the periodic table we have in class, and I just want to review the naming. So these numbers right here this is the atomic number, and the periodic table is organized by the atomic numbers. Then we have the two categories, groups. So groups are any columns. These are the vertical. And groups can be named two different ways. In this one that I have pointed, it can be the number 1 through 18. This would be group 15. Or it can have a number and a letter. The letter is A or B. And in this case, it would be the one that I have circled. It would be group 5A. We also can label any rows. So rows are these horizontal ones, and they're called periods. Periods have the numbers based on their location. If we start at the top with hydrogen being in period 1, and then we just number down. And so the one that I drew the line through would be period 5. Now we also can label the large areas of the periodic table. So the tall columns, they're all the ones that have the A, the letter A behind their number. These are all called the representative elements. It can also be called the main group. I have one textbook that calls them that. I feel like main group is a little more modern, but I'm not sure. So all these are representative. Then in between those tall columns, we have these here in the middle. These all have the letter B as a part of their group numbers. And all of these are called the transition elements or the transition metals. And then finally, we have the last big group on here. These are the inner transition elements or the inner transition metals. Now notice the inner transition elements do not have group numbers. So that is correct. They do not have group numbers. Only the representative elements and the transition elements have group numbers, but not the inner transition elements. And then finally, we know that 4 of the groups have their own names. Group 1A, except for hydrogen, these are called the alkali metals. Group 2A is called the alkaline, a little different, earth metals. So those are the 2 on that side. Then going to the right-hand side, group 7A is called the halogens. And group 8A are called the noble gases. So these are all the names that I went over in the previous slides that you need to learn. Now I have 3 slides that we can practice, just like some of the question types that you might find. So I encourage you to read the question and pause the video. Try to answer the questions, and then I'm going to walk you through it so you can check your answers, and if you're right, keep going, or if you're not, you can see how we would get it. So if I were you, I would pause it. All right, so let's do the answers. So I look letter A, an alkaline earth metal. Okay, so this is going to be group 2A. And you wouldn't have to write all this down. I'm just trying to think out loud. So that's this. And then in the 6th period, so the period is the row. So 5, that's 6 right here. So the alkali earth metal that's in the 6th period is right there, which is barium. Okay, so that would be the symbol. All right, so letter B, we got that one. The noble gas, so noble gas is in group 8A. That's these right here. So those are the noble gases. In the 3rd period, so here's the 3rd period. That period again means row. And so if we go across the 3rd period to the noble gases, we get to argon, which is right there. Now, letter C, the actinide with the highest atomic mass. So actinide are in the inner transition elements, It's the lanthanides and the actinides. And again, it's based on the name of the lanthanum and actinum. So that's why I know the second one is the actinides, because AC is there. And then the highest atomic mass, if you look through all the masses, it would be the last one that had the highest mass, which I think is LR. I think it might be lawrencium. We don't do very much in the inner transition elements. Sometimes we talk about uranium, but I don't know. It's just we're not down there very often. Now, letter D, a semi-metal. So remember on the heavy stair step line, these are along there, those are the semi-metals. So let me get a real light color and I'll just kind of mark them. So it's these. Remember, we did this when we were doing metals and non-metals. And so they want the semi-metal that's in group 3A. So this is using a Roman numeral, which is even more traditional than the number 3, but it will be the same thing. So here, which is a halogen. So you would have to know that halogens are 7A. So 7A is right here. And so then we would just look through. Calcium is here. That's not it. That's an alkaline earth. Oxygen is here. That's not it. That doesn't have a group name. Argon is here. That's not it. That's a noble gas. And then there's chlorine. So letter D is the answer. And one last question. So again, you might want to pause. All right, which is a representative element? So the representative elements are all the tall columns. And so you would just go through. Copper is Cu, not 1. Sodium, so sodium is definitely 1. Let's check the others. Iron is a transition metal, not here. Uranium is an inner transition metal, not here. So the answer is sodium. So again, just practice labeling, knowing the different areas, and be able to know them enough that given a periodic table, you could navigate using the labeling.